In this question, we are told that 1,800 centimeters cubed of fresh water of density 1,000 kilograms per cubic meter is mixed with 2,200 centimeters cubed of seawater of density 1,025 kilograms per meters cubed. We are required to calculate the density of the mixture. So this first container shows 1,500 centimeters cubed of fresh water of density 1,000 kilograms per meters cubed. The second container shows seawater. The volume is 2,200 and the density of seawater is 1,025 kilograms per meters cubed. The two liquids are mixed. They will mix up eventually to form a homogeneous liquid. So we want to determine the density of this mixture. How do we go about it? The first thing to recall is that if we want to calculate density of any mixture, we need to find its volume and its mass so that we can divide the mass by the volume to get the density. So we want to get the mass of this mixture as well as its volume. How do we do this? This liquid here is a mixture of fresh water and seawater. We have 1,800 centimeters cubed of fresh water mixed with 2,200 centimeters cubed of seawater. So we can get the volume of the mixture because the volume of the mixture is the sum of this volume here and this volume here. So we can add these two in order to get the volume of the mixture, and it will give us 4,000 centimeters cubed. So there is no problem with the volume of the mixture. How about the mass of the mixture? The mass of the mixture consists of mass of fresh water and mass of seawater. So we must calculate the mass of each liquid separately. And this is how we go about it. Now, before we embark on any manipulation of these figures, I'd like you to observe that the volume of the liquids is given in centimeters cubed, while the density is given in kilograms per meters cubed. It's important that we use units which are homogeneous. So we can either convert the volumes to meters cubed and then use the densities in kilograms per meters cubed, or convert the densities to grams per centimeters cubed and then use the volumes in centimeters cubed. Let us use the second method. We know that 1 gram per centimeters cubed is equivalent to 1,000 kilograms per meters cubed. So this one, the density of fresh water is 1 gram per centimeters cubed. This implies that the density of seawater, which we can call D2, is 1.025 grams per centimeters cubed. Its volume, which is V2, is 2,200 centimeters cubed. So we can work out M2, which is the mass of seawater. Mass is density times volume. And because it's the mass of seawater, which we have called M2, then it is the density of seawater, which is D2 times V2. And this will be 1.025 grams per centimeters cubed times 2,200 centimeters cubed, and this will give us 2,255 grams. Let's carry out a similar calculation for fresh water. The density of fresh water, we have already said it's D1 which is 1 gram per centimeters cubed. That is the density of this fresh water. Its volume, V1, is 1,800 centimeters cubed. So the mass of fresh water, which we can call M1, is D1 times V1. This is 1 gram per centimeters cubed times 1,800 centimeters cubed, and it gives us 1,800 grams. So we have the mass of fresh water and the mass of salty water or seawater. So we can effectively get the total mass of the mixture. So let's quickly calculate the density of the mixture, which we can call dm. D with a subscript m, density of the mixture. Since density is mass over volume, then density of the mixture is mass of the mixture over volume of the mixture. The mass of the mixture is M1 plus M2. While the volume of the mixture is V1 plus V2. We have already seen that M1 is 1,800 grams. M2 is 2,255 grams. V1 is 1,800 centimeters cubed. V2 is 2,200 centimeters cubed. And this gives us 4,055 grams. Divide by 4,000 centimeters cubed. So the density of the mixture is 1.01375, and the units are grams per centimeters cubed. This is the density of the mixture, 1.01375 grams per centimeters cubed. And we can convert that density into kilograms per meters cubed by multiplying this value by 1,000, which will give us 1,013.75 kilograms per meters cubed. It is just as simple as that. So remember, when you are asked to calculate density of a mixture of two liquids, remember to calculate the mass of the mixture and to calculate volume of the mixture. The two masses are calculated differently by using the same equation. Mass is equals to density times volume, or density is equals to mass over volume. So you calculate the mass of the fresh water separately, mass of salt water separately, and then add the two masses to give you the total mass of the mixture. Of course, the volume of the mixture is the sum of volume of fresh water and volume of seawater.